Welcome back, fellow mitochondriacs, for another episode of Cancer as a Mitochondrial Metabolic Disease. I'm really looking forward to getting back to talk to you all about deuterium, deuterium depleted water, deuterium depletion therapy. We have been on a little bit of a micro series of deuterium, first talking about how it's able to help improve glucose control, which ultimately will dovetail nicely into metabolic therapy because we have to keep our glucose tightly controlled, our glucose ketone index at a certain level as well for the other parts of metabolic therapy to truly work and make sense. Then we talked about what the potential mechanisms of how deuterium depletion therapy is believed to work, both talking about its ability to have cell cycle arrest for these out of control growing cancer cells, as well as producing increased ROS or reactive oxygen species or oxidative stress within these damaged mitochondria of cancer cells that allows them to unlock the previously shut down or inhibited apoptosis or programmed cell death pathways. So unfortunately, last time we got cut off due to me trying to do the video outside. But today we are comfortably inside. We have a good internet connection. And so I think we should be able to finally finish out the deuterium talks on a good note here. Now, one thing I will say is that, we've been talking about mechanisms. We've been talking about, potentially how it can help patients from a variety of angles. But what we have not yet been able to talk about, which I'm actually very excited to talk about, is deuterium depletion therapy's ability to have real life clinical outcomes for patients with cancer. And I'll refer to the book several times throughout this talk today, but for I guess I don't want to say most up to date, but definitely a body of work that is put together in a complete package. You may want to look at the book Defeating Cancer or Deuterium Depletion Therapy by Gabor Sommelier for the kind of complete story, as well as really more how to implement this in whatever kind of situation you're currently in. I'll give some generalities and some easy kind of start things to do while in this video. I'll kind of re-highlight those things. But in terms of like very definitive assistance with this, it's better to probably consult with the book and then consult with someone who, has an idea of what Gabor and or Laszlo's is talking about in order to really make this a reality for you. But until you do that, let's take a look at what I have to present today. Okay. Share. Alrighty then. So I was just listening to a podcast by Dr. Anthony Chaffee and Laszlo Sporos, and he was referring to this paper actually from one of the students, this Nicole Korchinski, who had done either a master's or a PhD level work with Laszlo Sporos in deuteronomics. And that's basically the study of deuterium throughout our metabolism in humans. And this is the paper he was referring to in that podcast. And I initially highlighted just the very small, portion of the lower part, because I think that's really what is the bottom line with the findings of this paper. But I wanted to read a little bit more because I think it could be helpful for us. So large variations in fatty acids and amino acid natural deuterium to hydrogen ratios in reference with solvent, water point, and active involvement of compartmental, intra, and intramolecular deuterium disequilibrium in adaptive biology. Yet the human deuterome is an untapped area of energy, metabolism, and health in humans. So this paper was published in October of 2024. And to make a statement like that, after all the work that has been done so far, I think is kind of scary, but also exciting at the same time, because we have a lot to learn still about these um, interactions. But it seems like that the work is hopefully going to be revived and start to be tackled, hopefully, by her and other scientists. The objectives of this paper was to propose the purpose of this scoping review was to examine the health effects through deuterium homeostasis using deuterium depleted water and or a deuterium depleted diet. We also aim to reveal health effects of nutritional, metabolic, and exercise ketosis, i.e., complete mitochondrial fatty acid oxidation with the production of deuterium depleted metabolic water. And it says here that 15 research articles were used. All retrieved articles were heterogeneous in nature, and additional themes did not evolve. Deuterium depletion was found to have beneficial effects in the following conditions: cancer prevention, cancer treatment, depression, diabetes, long-term memory, anti-aging, and sports performance. Deuteronomics is actively pursued in drug research, and there are biomarker roles attributed to large natural variations with adaptive significance in biology. And what I highlighted ultimately was, even with limited data, consistent deuterium depletion can be seen across all conditions reviewed. So I want to kind of dig a little bit into the paper itself. I mean, the paper is great, and we've kind of already talked a lot about the proposed mechanism, so I'm not really sure we get a lot more out of that, considering we're talking about clinical outcomes now. But I wanted to read a little bit out of the discussion. It says that the findings from animal studies indicate that deuterium depletion prevented tumor development and prevented the expression of cancer-related genes. The data further highlights smaller tumor volume and smaller tumor weight. Additionally, deuterium depletion shows a counteraction of a depressive-like state. Findings also show a reduction in blood glucose. Deuterium depletion in mice stimulated improved long-term memory, and anti-aging was demonstrated. Deuterium depletion in humans showed a delayed progression of prostate cancer. Deuterium depletion also showed improved mean survival time in lung cancer, glioblastoma multiforme, certain subgroups of breast cancer patients, small cell and non-small lung cell cancers, and advanced pancreatic cancer. In addition, deuterium depletion was associated with an absence of relapse of cancer patients, or basically a recurrence of disease once you have a stable or no evidence of disease situation. Furthermore, fasting glucose levels and fasting and reduced insulin levels were found in deuterium depletion depleted individuals with pre or manifest diabetes. And then I didn't highlight this, but increase in sports performance is also exhibited. So pretty cool. To summarize the main findings, deuterium possesses profound biological effects, and deuterium depletion has major roles. For example, the prevention of cancer development and various anti-cancer effects. It lowers the rate of depression, reduces circulating glucose and diabetes, stimulates long-term memory, increases lifespan, and enhances sports performance. Pretty amazing. What just looking at a simple, isotope of hydrogen, how it affects our body, and it really goes to show it affects the bioenergetics of the cell through mitochondrial performance. So let's look at a couple of studies that were done in vitro. One was done on nasopharyngeal carcinoma cells, and the paper was published in July of 2013. It's called Deuterium Depleted Water, DDW, inhibits the proliferation and migration of nasopharyngeal carcinoma cells in vitro. And it says here that these results demonstrated that DDW, or deuterium depleted water, is a novel, non-toxic adjuvant therapeutic agent that suppresses NPC, nasopharyngeal carcinoma, cell proliferation, migration, and invasion by inducing the expression of NQO1 and causing cell cycle arrest, as well as decreasing pCNA and MMP9 expression. And then the same kind of study was looked at using deuterium depleted water for these human breast cancer cells, these MCF7 breast cancer cell line. This was published in 2019. And it says, and the title is Deuterium Depleted Water Inhibits the Proliferation of Human MCF7 Breast Cancer Cell Lines by Inducing Cell Cycle Arrest. And it says here that our results show that treatment with deuterium depleted water, especially in the 30 to 100 parts per million concentrations, imposed the highest cell growth inhibitory effect. The cell cycle analysis revealed that deuterium depleted water caused the cell cycle arrest and the G1S transition, reduced the number of cells in the S phase, and significantly increased the population of cells in the G1 phase in these breast cancer cells. The activities of superoxide dismutase and catalyzed enzymes were increased in the same low concentration of DDW. In conclusion, DDW can open new strategic approach in breast cancer therapy, highlights DDW cause lethality in cancer cells. DDW augmented 5-FU, a chemotherapeutic agent, inhibitory effects on breast cancer cell line. Now, one thing that I saw in this particular paper that was a little bit of a concern to me, just got to keep it real here, is that the activities of superoxide dismutase and catalase enzymes were also increased in the same low concentration of DDW. So what that means to me is what we talked about, is that DDW is probably causing reactive oxygen species. But from what we've seen, DDW seems to inhibit some of these antioxidant systems, which was a little bit kind of surprising to me when it says that they saw the activities of superoxide dismutase and catalase enzymes were also increased. I guess that means that maybe the functioning available enzymes were increased because they were trying to, help with the oxidative stress, but it doesn't say that there was increases in amount of superoxide dismutase or catalase. So I might be a little bit consoled by that reasoning there. So the next paper I want to share was a paper that was done in 2008. And I'm going to share a little bit more of the paper as we go on here. But I want to say here that this paper was a retrospective evaluation of essentially 4 patients who had lung cancer with brain metastases. And it says that because of the number of sufferers and high mortality rate, the standard of care and therapeutic options in the treatment of brain metastases from lung cancer are the subject of intense research. A new concept based on the different chemical and physical behavior of protium, light hydrogen, and deuterium affecting cell signaling and tumor growth has been introduced into the treatment of cancer patients. The aim of the study was to investigate the impact of deuterium depleted water consumption, in addition to conventional forms of therapy, of the survival of lung cancer patients with brain metastases. And the study design was, there was 4 case histories with retrospectively evaluated. The patients were diagnosed with brain mets deriving from a primary lung tumor, and they started drinking deuterium depleted water at the time of or after the diagnosis of the brain mets, which means that was already stage 4, right? They had already passed a local tumor, stage 1. They have brain metastases, which means that these patients had a high level of mortality. And we'll get into the kind of the numbers as I dissect this paper here. And it says here that basically that the patients had inoperable they had an inoperable tumors in the brain, or the surgical intervention did not result in complete regression. And the primary objective was survival, which I think should be the primary outcome of most of these studies. When we start looking at very nuanced things apart from survival, it makes it really hard to know whether that is making a real difference or not. But I'll digress. It says here the method was the daily intake of these patients was replaced with DDW. which complemented the conventional forms of treatment. Patients were consuming DDW or deuterium-depleted water for at least 3 months. The treatment was continued with DDW of 10 to 15 to 20 parts per million deuterium lower content every 1 to 2 months, and thus a gradual decrease was maintained in the D concentration of the patient's body. So just to reiterate, these patients were getting gradually decreasing levels of deuterium-depleted water on the order of 10 to 20 parts per million every 1 to 2 months. And the results were that, actually, you know what? I'm going to get into the results when I get to the paper. So this is you can tell this is an old paper by looking at the font, but the bottom line is that the majority of clinical trials indicate the median survival time for people who have lung cancer metastatic to brain at about 4 to 6 months. So that's not a very good prognosis. That's actually that's a horrible prognosis. People who have, and again, could things have changed slightly? Maybe. This was published in 2008, but still the prognosis is very poor when you have brain mets, especially if their brain mets are inoperable or not available to be helped or resolved with the remainder of standard of care. So in a trial of stereotactic radiosurgery involving consecutive patients, including those suffering from advanced primary lung cancer and or multiple brain or other distant metastases, the overall median survival time remained 7 months, even with this stereotactic radiosurgery. In a study on recurrent small cell lung cancer, SCLC, with brain mets, median survival time was prolonged to by as much as 18 months by radiosurgery. The administration of this tyrosine kinase inhibitor led to a regression of brain metastases and resulted in the median survival of 8.3 months. So basically, they're saying that the average survival with stereotactic radiosurgery is 8 or 7 months. Excuse me. They had seen it to be as much as 8 months or 18 months. Excuse me. And with this tyrosine kinase inhibitor, gefitinib, it led to an 8.3. So basically, the 4 to 6 month survival time that was seen with the standard of care in the majority of studies could see slightly improved to 7 months with certain types of stereotactic radiosurgery and 8.3 months with this tyrosine kinase inhibitor. There are only a few exceptional cases of patients with brain metastases and lung cancer to survive a period of longer than 5 years. So keep that in mind. There's only a few cases of patients who actually survived 5 years with lung cancer metastatic to brain. So in the discussion of this paper, I highlighted some things that I thought were fairly important. So the deuterium depletion treatment itself did not cause any serious side effects. That's number one. Obviously, first, do no harm, right? We don't want to cause any harm. There was no serious side effects that were found. The anti-cancer effect and the safety of deuterium depletion were also confirmed in a large phase 2 human trial on prostate cancer. Although transient side effects might have occurred with DDW consumption was initiated, and when the D content of DDW was reduced, all of these events cease spontaneously at each given dose of DDW. So basically what they're saying is that even though there may have been some very minor side effects at the beginning, as they continue to reduce the deuterium for these patients, all of these cases spontaneously resolved in terms of like minor side effects they had with DDW. In spite of advanced primary tumor and brain metastases, accompanied with serious serious other syndromes, the status of all involved patients were markedly improved when they consumed DDW, in addition to the conventional forms of treatment. The combined treatment resulted in a complete response or a partial response of the brain metastases, or halted the continuous progression that could not have been stopped using conventional forms of treatment on their own. So basically, of these patients, they either had a complete response, which means they had no evidence of disease, or a partial response, or a halting of their progress that would not have been stopped by conventional therapy on its own. The evaluation showed that the patients received a remarkably long survival time. As far as we are aware, survival times of 9.7 months in one patient, 26.6 months in another patient, 33.4 months, and 54.6 months are unique in the annuals of brain metastases from lung tumors. So basically, they're saying this is a unique and not really ever seen survival time for people with this particular kind of scenario, where they have a primary lung cancer with brain metastases and an inoperable status. And when we've looked at other data in the 2008 era, that you had about a 4 to 6 month treatment with standard of care in general. Some of the patients who got some of these other things, like whole brain irradiation, stereotactic radiosurgery, or some of these tyrosine kinase inhibitors, maybe they live 7 to maybe 9 months. But in general, the patients who did the deuterium depletion therapy lived as long as 54 months. Again, this is a case report retrospectively on 4 patients, not a huge trial. That we have to obviously, admit. But it's still very promising and it's exciting. And frankly, like, you should think that, oh my God, like, we should look more into this, right? We should fund this. All right, we're gonna change gears. I put this in order of years. So this is another study that was done, and it was published in 2011, and it's called Deuterium Depletion May Delay the Progression of Prostate Cancer. And it says here that the efficiency of the method is based on the discovery that cancer cells are extremely sensitive to depletion of deuterium and might cause necrosis, or kind of non-programmed cell death or uncontrolled cell death of the tumor. The purpose of the study was to show the efficacy of deuterium depletion of prostate cancer patients in the double-blind, 4-month-long randomized phase 2 clinical trial of daily water intake was replaced with deuterium depleted water in 22 prostate cancer patients. Another 22 prostate cancer patients took normal water, while both groups received the same forms of conventional treatment. So they both got conventional treatment. One got DDW, 22 patients got DDW, 22 patients did not. Let's see here. The prospective trial, 7 patients in treatment group and 1 patient in placebo group achieved a partial response. In the treated group, the net decrease in prostate volume was 3 times higher. Urination complaints ceased at a higher rate, and the 1-year survival rate was also higher, 2 versus 9 deaths. The 91 retrospectively evaluated patients achieved a median survival time of 11 years, despite the fact that 46 of them suffered from distant metastases. So we're talking about metastatic prostate cancer living 11 years on average when they used deuterium depletion therapy. In the monitored patient, in the two monitored patients, the drop of PSA level correlated with deuterium depleted water intake. So let's take a look at this graph here. So this is looking at a treatment group, okay, 22 patients in the treatment group, 22 patients in the placebo group, 44 patients total, right? So in the people who got DDW, 15 of the 22 had a marked improvement. Unfortunately, I couldn't find any better, what do you want to call it, markers than PSA, but it's what we got. So they had a marked improvement, a decrease in more than 50% of their PSA dropped in 15 of 22 patients. Okay, that's a pretty big number. That's the vast majority of patients. Then 1 patient had a mild improvement, somewhere between 10 and 50%. So now we're looking at 16 of 22 having an improvement at all. 0 had been unchanged. 0 had a mild deterioration, and then 6 had a marked deterioration. So if you look at the 2 groups, in terms of a marked deterioration or non-responders, it was the exact same, right? We had 6 and 6. However, when you look at the marked improvement, we had basically, almost double the amount of people in the deuterium depletion therapy group had a marked improvement. Same with mild. Unchanged this is where we start to break away here. Had the placebo group had 4 people that were unchanged, 2 that had mild deterioration, and again, we had the same. So there's going to be a portion of the population that seems that DDW by itself is not going to be a standard. First of all, these are not standalone anyway, because these are done with people who got the standard of care in addition to deuterium depletion therapy. But there's going to be some degree of people who are potentially like kind of non-responders, or even who paradoxically get worse. I think that's to be determined, or to be maybe better understood. I would be curious to see, to understand maybe the mechanism of how that potentially would have worked. But I'll digress. This is what we have for progression of prostate cancer. Pretty exciting there. Then a later study that was done on the survival of lung cancer patients with the expression of KRAS, BCL2, and MYC genes in this mouse lung. And so it says here, this paper was published in 2013, and it says here that based on observations that deuterium depletion inhibits the growth of cancer cell lines and suppresses certain proto-oncogenes, we have conducted a clinical study of 129 patients with small cell and non-small cell lung cancers who consumed deuterium depleted drinking water as a non-toxic agent in addition to the conventional chemotherapy and radiotherapy. So again, these people are not getting DDW by itself. They're getting conventional therapy plus deuterium depletion therapy. And it says here that the median survival time, I don't know if this was metastatic patients or people who had just lung cancer in general. It doesn't tell whether or not it's just lung cancer in general or deuterium or metastatic lung cancer. But I'll digress. So what it says here is the median survival time for males was nearly 26 months. And in females, it was 74 months, I'll round down there, for female patients. The difference between the genders were statistically significant. Median survival times of subjects with brain metastases was 27.1 months. Now remember, again, this is a study that was done, several years later after the study that we looked at just a couple slides ago, where it was showing that people who had brain mets with lung cancer primary tumors, they lived somewhere between 4 and 6 months. And they were saying that the people who got deuterium depletion therapy on average lived 27.1 months. That's pretty unbelievable improvements there. Now, the gene expression analysis in the mouse lung indicated that DDW attenuates 7-12 DBMA induced expression of BCL2, KRAS, and MYC in females. In conclusion, deuterium depletion therapy counteracts this DMBA, induced overexpression of BCL2, KRAS, and c-MYC genes in mouse lung, and it may extend survival of lung cancer patients as a non-toxic anti-cancer dietary supplement, especially for women with tumors overexpressing cancer genes. Because of median survival time, the deuterium depletion consuming group was 2 to 4 times longer than the generally observed in lung cancer patients. So the median survival time was 2 to 4x if you did deuterium depletion therapy in addition to the standard of care, which is unbelievable. Now, I pulled these graphs up because you can see here that when you have, what they were basically trying to prove is that this DMBA, was responsible for the increased expression of KRAS and MYC and stuff like that. And then when you gave, 25, so they did it in basically normal water, 150 parts per million. And then they did DDW, and it showed the decrease in expression of these various very important proteins that are upregulating. We'll talk about again, just to give a refresher of what they do, or at least partially what they do. But you can see they added back in this DMBA, and there was the same response. So the bottom line is that this DMBA is at least partially responsible for the increases in KRAS, BCL2, and in these MYC genes within the mouse or within the lung cancer patients, and it is attenuated completely when you add in deuterium depleted water. So let's just go back as a refresher. Why do we care about KRAS, BCL2, and MYC in particular? Well, what do they do? So this is a graphic showing that when these KRAS or MYC are upregulated, we see when there's a lightning bolt what it does functionally within these cancer cells. And so this is SLC1A5, which is a glutamine cisporter. Okay, so it's bringing in massive amounts of glutamine. Okay, it's also upregulating GLS or glutaminase, the enzyme that DON, then bendazole, betulinic acid, berberine also likely blocks. It's upregulating this GLUD1, glutamate dehydrogenase. That's the enzyme that EGCG, quercetin blocks, as well as other glutamine related enzymes. And so you can see here, the reason why KRAS is upregulated in these cancer cells is because it wants to bring in extra, or what it does functionally is it brings in extra glutamine, and it's able for glutamine to be utilized in the cancer cells. So you can see how, this dovetails beautifully into metabolic therapy, because if we're well, I'll digress for a second of how it completely dovetails into metabolic therapy. But what I'll say is that, as we know in metabolic therapy, one of the primary goals is to lower the availability of glucose and glutamine, as well as lowering the ability for it to get inside the cell and lowering its ability to be utilized functionally inside these cancer cells, so that we can, growth arrest them, cut off their ATP supplies, cut off their glutathione supplies, and ultimately hit them with an oxidative therapy so that we can kill them. We see that KRAS and c-MYC are part of that story. Now, we also know that the hypoxia factors 1 and 2 are also a big part of the story as well, which I, again, will digress on. The bottom line is, we can see that when we do deuterium depletion therapy in a vacuum, we're seeing that we're having effects on the metabolic treatment of cancer, because we're downregulating these enzymes, because we're downregulating these proteins that are driving those enzymes to be expressed and ultimately utilized within this cancer models. What I want to say, when I kind of paused myself from saying, was that, true deuterium depletion therapy relies upon, again, very similar to metabolic therapy, the backbone being a ketogenic diet. So therefore, you can see how both of these strategies dovetail nicely into each other. I don't think Siegfried knows Laszlo Sporos or Gabor Sommelier. They may know each other, but they are definitely two different areas of science looking at a very similar problem. How do we lower glucose and how do we lower glutamine? It seems that deuterium depletion therapy does both of those things. And in addition to that, it also does other things within cell cycle, et cetera, that is kind of not within the metabolic therapy of cancer. But that being said, it does dovetail nicely. I would also say that the only thing different that you would have to do in order to enhance your metabolic therapy that you're already on with a therapeutic ketogenic diet for metabolic therapy would be to drink water, because you're already doing deuterium depletion therapy in some ways just by being on a ketogenic diet, part of metabolic therapy. So let's look at a couple of the heavy hitters here, not to minimize, breast cancer, not to minimize any other cancers, especially the lung cancer metastatic to brain, which has a terrible prognosis as well. But some of the cancers that are very scary, that, unfortunately modern medicine has very little to offer, and has really not shown a lot of advances in the last, 100 years, especially when it comes to glioblastoma multiforme. So the first study I'm going to show was published in July of 2023. It was titled "A Preliminary Study Indicating Improvement in the Median Survival Time of Glioblastoma Multiforme Patients by the Application of Deuterium Depletion in Combination with Conventional Therapy." And I think that what I'll do is I'll start out by just reading the first part of this abstract. Glioblastoma multiforme and malignant gliomas are the most common primary malignant brain tumors. Temozolomide, TMZ, chemotherapy plus radiotherapy, RT, administered after debulking surgery, increased the median survival time from 12 months with radiation therapy alone to 14 months respectively. So if you got radiation therapy only, you basically lived 12.1 months on average. And if you got surgery and TMZ in addition to radiotherapy, you lived about 14.6 months. So basically with maximal standard of care therapy, okay, we're talking about invasive brain, surgeries, radiation to the brain, chemotherapy, you're getting about 2.5 months additional on average of survival with this horrible brain cancer. Without changing conventional treatment, the daily. So basically, sorry, I missed this part. In this study, the actions of deuterium depleted water on the survival of GBM patients who also received conventional therapies were investigated. So basically, they got the standard of care, but then they got DDW in addition to it. Okay. Without changing the conventional treatment, the daily fluid intake of the patients was wholly replaced with DDW, deuterium depleted water, in a 1.5 to 2 liter per day volume. Okay, not a huge amount of this water was even required. And I don't believe that they even made them be on a ketogenic diet, which would have made it even better, probably. Okay, I'll digress again. The primary endpoint was median survival, which again is the most important. The 55 patients involved in the study received conventional treatment and consumed DDW showed a longer median survival time. So they lived 30 months. So the best of standard of care gave you 2.5 months. Adding that standard of care to deuterium depleted water, just the water, not in the ketogenic diet, just the water, showed a median survival time of 30 months. So we're talking like, 2.5 fold increase of longer survival just by doing deuterium depleted water in addition to standard of care, compared to the historical control of 12.1 to 14.6 months. There is a massive difference between the genders in the calculated median survival values. It showed a 25 months in male subgroups and 42 months in female subgroups. So again, like we saw in the lung cancer model, in the lung cancer patients, females in the lung cancer model, gosh, what was it? That's not it. So the males with lung cancer lived 26 months with deuterium depletion therapy in addition to the standard of care, 74 months for females. So my God, I think that if it was me, I would totally do deuterium depletion therapy in addition to being on metabolic therapy since I'm a male. But if I was a female, or if I had a female that I loved and care about, and they had these type of cancers, God, they're doing so much better than the median survival. Wow. And it's no different for this malignant brain cancer, glioblastoma multiforme, GBM. Females live 42 months compared to the standard control of 12 to 14 months with just deuterium depleted water. And the males lived 25 months. So males, we don't do quite as well as the females, or not nearly as well, really, if you really break it down. So let's look again next at another cancer with terrible prognosis, and that would be, pancreatic cancer. Let's see here. So they looked at 86 patients, 36 male, 50 female, with pancreatic adenocarcinoma, or the primary, type of cancer that's found in the pancreas. I'm not saying there's not other types of cancer, neuroendocrine tumors, et cetera, but the primary, most common cause of pancreatic cancer is adenocarcinoma. Patients treated with conventional therapy, chemotherapy, and natural water. So there was a control group. There was 30 patients that got conventional therapy, chemo, and natural, just normal deuterium water. Or 56 patients got 85 parts per million DDW in addition to standard of care, which was gradually decreased with 65 parts per million and subsequently 45 parts per million at the 1 to 3 month treatment period. Well, content for each 1 to 3 months. Okay, yeah, okay. I was correct. I thought they only got 1 to 3 months total DDW, but they actually, at 1 to 3 months, they lowered their DDW water by about 20 parts per million, from 85 to 65 and the 65 to 45 respectively, over about a 9-month period, it seems like. And the median, okay, so the median survival time for patients consuming deuterium depleted water treatment in the treatment group, the 56 who got it, okay, in addition to standard of care, was 19.6 months. Still horrible, but the people who got the standard of care alone lived 6 months, 6.3 months. So again, we're talking about a 3x plus fold increase in survival just drinking deuterium depleted water. These people are not on keto. They're not getting IV vitamin C. They're not getting HBOT. They're not getting DAWN or glutamine blockers. They're getting deuterium depleted water. Okay, that's it. That's all they got. I don't know if it shows the amount, but in general, they give about 1.5 to 2 liters per day. So you're drinking a liter and a half to 2 liters of water a day. You're tripling your survival time. Chemo's not going to do that. Radiation's not going to do that. Surgery's not going to do that. This is an unbelievable finding. Again, it's 85 patients total in the study. It's not a huge study, but the bottom line is that the results were significant, and they, in terms of like statistical analysis, but also significant in terms of time on the earth, God willing, of course. So I think that this is a no-brainer in terms of being willing to enhance your metabolic therapy, okay? Completely no-brainer. That being said, I'm not suggesting this is easy. Not because it's not easy to drink a liter and a half or 2 liters of water a day. That's easy. But what I would say is that DDW, or deuterium depleted water, is not cheap, okay? Because there's such little supply and there's probably a decent amount of demand, the water is not cheap. So that's the issue at this time. Hopefully as this information gets out more and people understand about it, and maybe other companies and things can get into the space and they can make it for cheaper. In fact, I was talking to one of my clients, and he believes that you can make a liter of deuterium depleted water for like less than $2, but they sell it because for whatever reason, they sell it for like, well, a liter, God, we're talking like $20, right? So I do think good things are happening with the right, people, hopefully steering this in the right direction. But you do have to be careful, because there are companies out there, one that in particular that I really wanted to believe in, that I've heard some horror stories of water that was labeled at 5 parts per million that truly had 50. And even in one case, I heard 150 parts per million water when they actually tested it on a third party. Okay. So we're talking about someone putting tap water into, it may be filtered tap water, but it's basically tap water into a bottle of deuterium depleted water, quote unquote, labeling it as DDW, and you're not getting it. So at this point, I'm only personally really recommending 2 companies, of which I have no affiliation, but it's companies that seem to actually have good quality control and truly deuterium depleted water. And I'll digress on that, and we'll talk about it at the very end. So let me take a look real fast. Any questions? Information is gold. I appreciate that. He is still alive. I am still, if you're talking about me, I'm still alive. Yes. Scarborough, yummy. No, I have not. You're talking about he is still alive. Okay. I'm reading from down up. My bad. That's awesome. How long did he live for? How long has he lived? Yep, I agree with Access 2. Just joining, was in transfer to the hospital. Another bad UTI. I'm sorry to hear that. Okay, so let me quickly go into some strategies to actually naturally deuterium deplete apart from the water side. So just as we kind of talked about at the very beginning of this, okay, let me see if I can go back to this slide. As we decrease latitude, we increase deuterium content, okay? As we increase latitude, we decrease deuterium content, okay? So that would make sense based off of what we're seeing in terms of food, okay? So I'm gonna start with the carbohydrates. So coconuts, which are gonna be obviously equatorial, are gonna have a higher parts per million. basically like where you're growing carbohydrates that require, like temperate climates or warmer climates, you're going to have higher parts per million. But in general, it's not just the latitude of food. It's also just the fact that the higher carbohydrate parts of food concentrate deuterium compared to the fat parts of the plant. Because if you look at, for example, avocados, you can see a much lower deuterium. We're talking like 25, 26 parts per million lower in an avocado compared to a fruit or a carbohydrate rich, kind of food from a plant. We can see that, grass-fed meat, 138, grass-fed animals, 128. You can see that really salads on average, green leafy vegetables don't seem to concentrate deuterium quite as much. Plant source of fat, olive oil, nut oils, sunflower oil, about 130 on average parts per million. Cottage cheese, 136. Butter and ghee and those kind of things, 124 parts per million. Peanut butter, again, I'm not saying these are health foods or not health foods. I'm just saying that in general, the higher fat content of foods have lower parts per million. So peanut butter, 132. Cacao butter, 132. And lard, 116 parts per million. And then going back to waters, we can see seawater. This is likely an equatorial seawater at 155. Coconut water, again, because of the equatorial nature and tropical nature, it's probably a higher deuterium content. And then distilled water doesn't really do a whole lot. So you're not going to get much by distilling your water or doing RO to the water. It's not going to do much at all to the deuterium content. As we get to the higher, Icelandic waters, you're going to start to see the deuterium concentration decrease. Evian and Voss, I'm not familiar with this brand at all. Maybe some of the Europeans, something like that, I don't know about it. But Voss, I'm familiar with. Icelandic, I'm familiar with. Pellegrino, I'm familiar with. Evian seems to be the lowest natural deuterium depleted water commercially available. Now, I have heard anecdotal stories of people who write into me or comment on videos that they had. You can have your water tested. Okay, Light Water will actually do it for you. They'll test your deuterium water of your local environment. And I've heard people have 135 parts per million in their local environment. So that's freaking awesome. I mean, if you have that available, just make sure it's RO or distilled or something like that to take all the other crap out of it. But you got some low deuterium water to start with. And then there are brands available. This is the book I was referring to, Dr. Gabor Somalier's book, Deuterium Depletion. He has another older book called Defeating Cancer. This is his newer book, and it's information packed. It's kind of a difficult read, but I would say it's got a lot of information, needless to say. And Gabor is kind of the true expert in this field, and so you're going to be getting it from the man himself. Now, Preventa, you can see here they have 125, 105, 85, 65, 45, 25 parts per million. From a convenience standpoint, it's the best because it's 1.5 liters already. So you're already at your number you need. And you can start to step down. So let's say you started at 85, which is where I mostly have clients start out with, about somewhere between 70, 80 parts per million. And getting, stepping down, you can step down at the 3-month period, kind of down to 45. And so my point is that this Preventa makes it very easy. You're already getting the amount and you're getting a very specific concentration of deuterium, so you can make things easy. The issue is at least in my experience, this stuff is out of stock continuously. So again, supply is low, demand is high, pricing, of course, is going to be respective to that. The water that I generally recommend for people in the United States, just because it's available on Amazon and it's available, it's about the same cost, is Light Water, LITE water. They have a 5 and 10 parts per million. They come in plastic or glass. Obviously, if you have the ability to get glass, that would be the better option, but you got to do what you got to do. And that would be a way to get, deuterium depleted water. Now, what I'll say is I don't see much of a role, both from the glucose side of things, from the cancer side of things, of drinking 5 or 10 parts per million. The goal is to use this 5 or 10 parts per million and cut, a lower deuterium naturally occurring water with DDW. So let's say hypothetically you used 50-50 of, let's say, I don't know, let's just say Evian at 145 parts per million. You get, a liter of each or half a liter of each, whatever you want to say, and you cut it 1-to-1 with 10 parts per million, you'd be looking at about, 70 something parts per million deuterium depleted water. That's probably the easiest way to do it. Now, if you have the ability to get the Preventa at whatever specific parts per million you decide and you and your healthcare provider decide is right for you, then that's probably the easiest and best way to get it. It's just that because it comes in 1.5 liters, it's already cut to the amount you need. It's just that in my experience, I have not found that Preventa is ever in stock. Every time I ever go to the website, it's always out of stock, like every single bottle. So, you know, it makes it difficult to really recommend that as a company. Not that they're bad. I think they're great. It's just that it's just hard to get that for real-time use. There are other companies on the internet, on YouTube, or not YouTube, on Amazon. Again, I cannot vouch for those. And no matter what, you know, it probably would not be a terrible idea to get whatever bottle you use, you know, independently tested. You know, Light Water and Preventa, you probably don't need to do that because they have a high degree of quality control. But the other companies, whatever you buy, if it's a cheaper brand, probably, you know, getting it tested, third-party tested, to make sure that it's actually truly the light water, LITE water that you want at the concentrations you want, so you can implement this, you know, or dovetail this therapy into metabolic therapy. I think it would be a smart move. I also would say that, you know, again, I cannot underscore how much I recommend or think that this could be dovetailing beautifully into metabolic therapy as a whole. Yeah, you know, Sarah, you make a great point. So expensive, just like ketone drinks. I will tell you this. I don't know of any ketone drinks that can 3 to 5x your survival time from these metastatic cancers like DDW can. So, you know, the question is, where is your money best well spent? If it was me, I would say deuterium depleted water is a much better investment. But that's for you and your healthcare team to decide. But yeah. Well, let's see here. Is any other DDW is not cheap? No, it's not. I'm so glad I get to watch these videos and learn. I'm so glad that you're able to listen to these videos and learn. I'm happy to provide whatever information that I learn also and transmit it back to you. You're welcome for this video. I think that we pretty much have hit deuterium depletion therapy. We've hit its effects, you know, on the biologic systems of glucose and insulin and stuff like that. We've seen how it affects cancer and in terms of its approaches or how they believe it works or fundamentally works. And now we've seen clinical outcomes, real clinical outcomes. Are there need to be more studies? Absolutely. Am I satisfied with what we got? Absolutely not. But I'm very encouraged and I'm very intrigued by the data we have. And I really hope that they can get, you know, the funding they need to continue this important work. And hopefully one day this will become part of the standard of care for patients. Maybe, God willing, it'll be even covered by insurance. And no one has to actually pay for this out of pocket. Do you know if distilled water has less deuterium? I don't. So believe it or not, there's various types of ways of distilling water. Normal distilling water that we have like on our countertop or what we can do at home does not really affect the deuterium content of the water much, if not at all. We're talking like 1 to 3 parts per million per distillation. So no, you're not going to get the water you need using a home distiller. Trust me, I've thought about that. I have a home distiller. I use it, but it's not going to give me DDW. All right. Well, we've gone about 54 minutes. I'm happy to be back with you. If you have any questions, just leave them in the comments later and I'll try to get back to you as soon as I can. And I hope this was helpful. If you know anybody who could use this information, please, you know, like it, share it with them. And until next time.